Okay, let's do a few more examples of finding points on the f of x graph given the derivative and a condition. So let's try this one. The graph of the derivative is shown. We're given that the point exists at 410. Evaluate the point at -4. So we want to know the y-coordinate when x equals -4. Now this one, if you notice, the graph of the derivative is positive and it's negative. So that means the original graph is increasing and decreasing. It has a critical point at 0. It changes from positive to negative here. So there's a maximum on the original graph at x equals 0. And there's a horizontal tangent line here. There's a horizontal tangent line here, which means that's where the second derivative is going to equal 0. And because the tangent lines are changing from positive to negative, we're going to have points of inflection and concavity changes. So we're increasing from -4 to 0 because the derivative graph is positive. It's concave up here and then concave down here. Continues to be concave down. There's the maximum. And then we're going to be concave up again, and we're going to approach a horizontal tangent. Horizontal tangent here too. So let's try to graph this thing. We're going to start at -4 with the horizontal tangent. It's concave up because the slope of the tangent line is positive. And then it's going to turn into concave down after this point of inflection here because the second derivative is 0 there. We're talking tangent lines of the derivative graph, means I'm talking about the second derivative. So we're concave up until we get to -2, and then once we get to -2, it changes to concave down, something like that. So there's a point of inflection right here. Okay, now at x equals 0, there's a flat. The derivative is 0 there. And then it now changes to decreasing. So there's a maximum there. And we're still concave down because the tangent line is still negative. But once we get to x equals 2, we're going to change again to concave up again. So now there's another point of inflection right here. We're going to flatten out again at x equals 4. Okay, so, and this really should look a little more symmetrical. I should have made this down a little lower. This graph is symmetrical. So that means the slopes of the graph are the same, pretty much. So this point and this point are the same. F of -4 is going to be the exact same thing as f of +4. So they both equal 10. And that's just because of the symmetry of this graph and knowing that the general shape made it look like this. These are going to be identical. Short and sweet. Let's move on to the next one. Okay, so now this one, again, is changing from increasing to decreasing, actually from decreasing to increasing this time, because it has a negative first derivative value and then it has a 0 here. There's a critical value here because the first derivative is equal to 0 and it changes from negative to positive. So it's going from decreasing to increasing right here. And then it's increasing forever here. So, okay, let's just look at the question though. They're giving us f of 4. They're asking us to evaluate f of 0. So from 0 to 4, it's increasing forever. We don't even really need to look at this part of the graph because I want to know the point at 0. I was given the point at 4. It's increasing the entire time. So because f of x is increasing from 0 to 4, f of 0 is going to be less than f of 4. This is similar to the ones we did before. So we know that this point at x equals 0 will be less than this point. So we need to find the distance traveled again from 0 to 4 and then subtract that amount. I'm not even going to graph this one just because we know, because of the fact that the derivative is positive, this graph is increasing. F of 4 is up here, f of 0 is down here. So once we find the value of f of 4, we just need to subtract it to figure out what f of 0 is. So find the area of this trapezoid, which is 1/2 times the height. The height in this case is 2, and the bases are 4 and 2. Comes out to be 6. So our total distance traveled is 6. So f of 0 is going to be our point that we know, which is going to be the maximum. F of 0 is going to be the minimum, in this case, just from 0 to 4, the absolute minimum. So f of 4 minus 6 would be 1 minus 6. Our answer would be -5 in this case.